Hi, welcome back to my channel. Well, in this video, I will demonstrate about a very important web app which we have developed that is known as DendroFit, which is a smart app for tree high diameter modeling, which is designed to support for a scientist or the researchers in forestry for understanding the dynamics that exist between tree height and diameter. These two are very important, or I can say the prime dendrometric variables in forest inventory as well as in management. Although diameter at rise height or DBH, it can be measured very easily without any difficulty, but due to the visual obstruction sometimes in forest stands, the measurement or the estimation of height becomes difficult, especially when the tree stands are very tall or the canopies are closed. Now, what are the options available in those situations? Under those circumstances, high diameter model plays a very important role. What these models do, they actually predict the height of the remaining trees, which are very difficult to measure, so thereby reducing the cost of the data acquisition. So they play a very vital role in high diameter relationship, these high diameter modeling. Ultimately, for volume estimation, growth analysis, growing stock, so all these things are interrelated. A lot of high diameter models are available in literature and which are being quite frequently used, but when we talk about the deployment of these models, they involve a series of steps. First, we have to fix the initial parameters, then apply the appropriate validation technique, then apply so many selection criteria or selection matrices, because we want to test the reliability of the model from different perspectives. So a lot of series of steps are involved, and especially if we are analyzing or deploying so many higher diameter models, especially in R Studio or R, a lot of series of cumbersome steps are involved. So in order to overcome these, we have developed a user-friendly application that is known as DendroFit, which can take care of all these difficulties, and where a lot of almost 11 tree high diameter models can be analyzed, deployed in a one click of a button. So this DendroFit is a smart web app for tree high diameter modeling. So a lot of high diameter models are implemented in this, like Nasland, Kurtz, Mitchell, Power, Wyckoff. The first thing is that we have to upload the CSV file. Then we have to select the column. One represents to diameter and another one represents to height. Then we have to choose the models which we want to fit on the data. Then apply the cross validation, which is very important to test the reliability of the model if we want to test the model performance. Then click on this run analysis so that we can view the results. So this is about the developers, and this application has been made in R. It's a Shiny based app, and a lot of packages are involved in this. ggplot, wonderful data visualization pack, min pack, matrices, and DT. These are so how we are going to use it. The first thing is that we have to click on this data. So this is the dashboard here. That is the let us click on this dashboard first. Here it is height versus diameter. We'll be having a plot here, then quick status, which are the best model performance. Then how we are going to use is that we have to click on this data. Then if we will browse on this data, so that we will find out where, since my data set is HT. So click on this open. Here this is the diameter column and this is the height column. Then if I will click on this run, okay, then what we have to do, we have to go on this section, click on these models. Already it has chosen some model. Let us choose some more. Nasland. So if we will click on this run analysis, so all these models are chosen here. This is the data visualization of height and diameter. Every model is represented by a different color, and this is very wonderful data visualization. This solid blue color pertains to power. As you can see, it is almost capturing a very good amount of relationship between height and diameter. Now this is the model parameters for Nasland, the coefficients for this. Similarly for Kurtz, for Mitchell, Nasland, Power. The best model in this case is Power, as it has got the lowest root mean square error, and this is the summary statistics about this model. So you can see all these models are performing well since their R-square coefficient of determination is quite high, but among them power is having an edge in a way that it has got a high value of R-square and lowest value of these from RMSME to prediction error rate. Now let us go to this cross validation. Also we have another visualization for training as well as testing set. Again we have models for these. Again this is for testing. Again it is having the highest value of R-square and lowest value of this, and similar is the case with this training also. Let us go to the dashboard. Now the total number of observations are 300. Power is the best model among all these. We have a prediction accuracy of 86.7%, which is tremendous or very good. And you can see this is the final model of between height and diameter. Among all these models which we have used in this, let us go to this model. How many models are there? 1, 2, 3, 4, 5, 6. Among six, Power and Nestland are the best performing models, but among these best performing, Power is the prime model. I can say it is the final deployed model which is recommended for this kind of height and diameter relationship. So this is a very wonderful app in a way that you don't need to rely on hardcore coding, so you can perform all the analysis just the click of a button. You don't need to set out the initial parameters or anything of any kind of a coding you have to do. So in order to get the link for this app, I'll be giving the email ID on the description of this video, so that the people who are engaged in this kind of stuff, this kind of work, they will be able to deploy all these models. Hope you will like this video. Thank you very much.